Alright, so we've been looking at exponential functions, and today we're going to look at how to solve exponential functions. We looked at how to graph them. Today we're going to look at how to solve them. Alright, so Chapter 7, Topic 3, Solving Exponential Equations. Rewrite both sides of the equation with the same base. Set the exponents equal to each other, and then solve. Alright, so what that means is that both sides of the equation need to have the same base. Alright, so when we look at number 1 and we see 2 to the x plus 8 equals 1, or wait, I think I said that backwards. 2 to the x plus 1 equals 8, we see that the left side has a base of 2. Alright, so we see we have a base of 2 here. So that means that the right side is also going to need to have a base of 2. So I need to write this as some exponent of 2. And we know that we can rewrite 8 as 2 to the third power, because 2 cubed is equal to 8. Now, what this is telling me is that this and this must be equal in order for these to be the same thing on both sides. So I can just write x plus 1 is equal to 3. And in this equation, I can solve x is equal to 2. And that makes sense, because 2 to the 2 plus 1 equals 8, 2 to the third equals 8. Right, so we can plug this in and check to make sure that it works. 2 to the 3 equals 8, and that is correct. So our answer here, x is equal to 2. All right, number 2, we got 4 to the 2n minus 1 equals 256. All right, so we need these both to have the same base here. They need to both have a base of 4. So this is 4 to the 2n minus 1 equals 4 to the 4th, I think. Let me double check this. 4 times 4 is 16. Times 4 is 64. Times 4 is 256. Yeah, so 4 to the 4th power. Alright, so this is telling me that these exponents must be equal to each other for these two equations to be equal to each other. So 2n minus 1 must be equal to 4. And then we can solve this. 2n equals 5. Divide by 2. So our solution n equals 5 halves. All right, number 3, we got 5 to the 5x equals 125 to the x plus 2. All right, well, this one's a little bit harder because they already have exponents, they already have bases, but they have different bases. This is 5, this is 125. So that means we need to rewrite 125 as a base of 3. As a base of 5. So this would be 5 to the 5x equals, and we can rewrite this as 5 cubed. 5 to the third power. Okay, well, remember our property says that if we raise a power to a power, then those need to get multiplied. So this 3 is going to get multiplied here because what we're actually looking at here, because the property says x to the a, here's how the property works. X to the a raised to the b power is equal to x to the a times b power. And that's the product property, or the power of power property. So what we're looking at here is 5 to the 3 times x plus 2, 5x. So of course that we distribute, so that's 3x plus 6. So now that we both have a base of 5, the exponents must be equal to each other. 5x must be equal to 3x plus 6. And we can solve this equation. Subtract 3x, 2x equals 6, divide by 2, our solution, x equals 3. So it's all about rewriting the problem so that you have the same bases. All right, we got a couple more here. All right, so number 4, 3 to the 2x plus 4 equals 1 over 9 to the x. Okay, so once again, we need to write these as an exponent, or as a base of 3. All right, so this one's fine, 3 to the 2x plus 4. But we got to remember, how do we write 1 over 9 to the with a base of 3? Well, that would be 3 to the negative 2 power, because remember, the negative would put this is technically 1 over 3 squared, which is 3 to the negative 2 power. And then that's the power of a power. You just multiply them. Whoops. 3 to the negative 2x. All right, so now we see the bases are the same, so the exponents, in order for these two to be equal, the exponents must also be the same. So they have to be equal to each other. 2x plus 4 has to be equal to negative 2x. All right, so I'm going to move this 2x to the other side over here. We got 4 is equal to negative 4x. Divided by negative 4. X is equal to negative 1. So our solution for number 4, negative 1. And of course, we could plug that in and check to see that it actually works. All right, so don't let these fractions throw you off, okay? The fraction just means it's supposed to be a negative exponent. So when we look at number 5, 1 to the 5th, 3x plus 1 equals 25. These both need to be to the 5th with a base of 5. So this is 5 to the negative 1 power to the 3x plus 1 equals, and this is 5 to the second power. All right, well, we have to distribute because they're being multiplied together. So I have to distribute here. So this would be 5 to the negative 3x minus 1 equals 5 squared. And now that the bases are equal to each other, I can set the exponents equal to each other. So I can set negative 3x minus 1 equal to 2, and then solve. Add 1. Negative 3x equals 3. Divide by negative 3. X is equal to negative 1. Okay, so same answer. That was just a coincidence. But number 5, x is equal to negative 1. And just for fun, let's go ahead and plug that one in and see that it works. So 3 times negative 1 plus 1, 25. So that's 1 over 5 to the negative 3 plus 1 power, which is 1 over 5 to the negative 2 power, which is 5 squared equals 25, which is true. That is in fact true. Okay, so plugging it in, it gives us a number that makes sense. All right, so number 6, we got 9 to the 2x equals 27 to the x minus 1. Now here you might be saying, well, I can't make this a base of 9, so what am I going to do? And the answer is that we need to make them both a base of 3. Okay, we need to change them so that they're both a base of 3. So 9 is 3 squared, so this is 3 squared to the 2x, and 27 is 3 cubed, so it's 3 cubed to the x minus 1. All right, so this is 3 to the 4x equals, and remember we got to distribute because they're being multiplied. So this is 3x minus 3. And now we can set the exponents equal to each other. So 4x equals 3x minus 3. All right, minus 3x. So x is equal to negative 3 for number 6.